Hey,
How are you?
good. I never heard you sing happy birthday.
I did.
Oh, you did?
Yeah, with Dr. Grisso. She
I just thought I would hear you from over here, but I didn't.
Are you calling me loud?
No, I just...
I think she closed the door behind her, so I don't know. Me and Dr. Grisso were the only ones to sing. So.
Oh, yeah. Well, I was going to go tell her, but
Tell her what?
happy birthday.
Oh.
But then she went in there when I had time to go. Yeah.
Is there anything that I was supposed to grab or turn in on Friday?
Yes, you need to watch the class recording to know what you missed. But I collected one assignment, and there were some more handouts that would be over there.
Okay.
But I can't remember every little thing, so.
Okay, I'll check.
Look, right. I beat him at the square game. After losing like 7 times. No, the final record was like, what, 8-7? And I was victor out of, was it 15 rounds?
Yeah, but I didn't even lose.
You don't lose?
I said I didn't even lose at it.
You didn't play, did you?
I still didn't lose.
Well, if you didn't play, you didn't win any.
That's true, but I also didn't lose.
We'll have to play.
You've got like 20 years of experience at this point.
Me?
Yes.
I'm not even playing all this 20 years old.
You've played like 10 times more games than I ever have, probably.
Oh. It's your game. Play during advisory.
Some days my advisory don't want to do anything.
Well, you need to whoop them in shape.
And some days they're actually doing homework, so I'm not going to distract them from being productive.
I don't really do homework in advisory.
Well, you're supposed to.
Well, yeah. But you never really get around to it, you know?
That's why you do it first. Then if you want to get to something else, you get around to it.
To be fair, I'm good with homework in this class.
Do what?
I'm good with homework in this class.
That's because there's been almost no homework.
I have 67 and 65.
Nobody's complaining, right? About how much homework he's given us? Yeah, it's amazing. We appreciate you as a teacher and as a friend quite much.
Well, that's for the wrong reasons, so.
I've learned quite a lot.
We'll see when the test comes around.
Oh, yeah, that's true.
How much of it you remember?
I got 100 on first quiz we had,
It's true.
so that's a first time for everything.
That means you got to make 100 on the second one, or your grades are going to drop.
True, yeah. What do I have in this class now? I think I have 100. So I feel like if I get one thing wrong, my grades are going to drop.
Yep. That's how averages work.
Yep. Diego, I saw you and your sister driving to school the other day. You drove behind me. She drives a Nissan.
Here's number
Okay.
65.
Okay.
In the basket, please. Thank you.
I was trying to like think of a way to say hi, so I just kept on like spamming my rear windshield wipers.
What?
Like waving.
Isn't that like a sign that you're too close behind or something?
I don't know. I've never heard that before. I think it's brake check on somebody's
What did I miss Friday?
You'll need to check the class recording that I sent to you.
Oh, come on, Diego. Luke, did you?
I did. You gotta take some risks sometimes, you're good. If you got a 40 mile per hour
I've made the
semi
mistake
behind you,
before,
you're
you didn't have to
close.
I fell asleep immediately after. I'll read you. I slept like 14 hours.
You know what I did after we
Okay, let's go ahead and get started here today. Our assignment today should not take the whole time again, but we got a bunch of little things. So first off, we're going to learn something new with number 70, and that is how to evaluate what's called an infinite limit. That's the two-sided piece of paper y'all picked up today. Two-sided piece of paper is number 70. Then I'm going to have you practice a few of those, which should take about 5 minutes or less on 71.
There's two.
Oh, I'm sorry, the one with 3 graphs on the left side is 70. The one with no graphs on it, one-sided piece of paper, is 71. So you're practicing. The third piece is, since that is so short, because we actually did that on a Fast Friday last year, I put together a mid-unit review. So just like 2 or 3 questions from what we did limits on day 1, day 2, day 3, day 4, up until now, just to give you kind of a benchmark of, are you remembering the things that we're doing and setting yourself up well for when we do get to the quiz. And then finally, I'm going to take up one more assignment today, which will be number 67. That one's from a few classes ago, but I will remind you of that once we get there. Okay, for infinite limits, about 95% of this work is really just remembering something from Algebra 2. Now, even if you don't remember this, this is good for you to know because this is also on the ACT. But we need to know the 3 circumstances, the 3 conditions for horizontal asymptotes. And then I'll tell you what that has to do with calculus. So what you need to do is compare the degree of the numerator to the degree of the denominator. Degree numerator to degree of denominator, and 3 different things could happen. Either the degree of the numerator could be bigger, the degree of the numerator could be smaller, or the degrees could be equal. That's why there's 3 rules that you have to know for horizontal asymptotes. When the degree of the numerator is bigger, in Algebra 2 you should have learned that there is not a horizontal asymptote. When the degree of the denominator is bigger, it would have a horizontal asymptote at y equals 0. And if the degrees are equal, you would have a horizontal asymptote at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Does that stuff sound familiar? Those rules? So if you know those 3, or you relearn them, and you learn what a horizontal asymptote is, which I'm about to tell you, then you can work another type of calculus question. Because again, this is really the bulk of the work. So of course the ACT is not going to ask the calculus version, but they would ask this stuff about horizontal asymptotes. So what a horizontal asymptote is, well actually let's just look at this example. So if I compare the degree of the numerator to the degree of the denominator, the degree of the denominator is bigger than the degree of the numerator. So what does that tell me about the horizontal asymptote? Okay, so y equals 0. Now here's the connection that you have to make. A horizontal asymptote is the number that your graph approaches on the far left and far right of the graph. So again, we don't normally have a graph, but I went ahead and put it here for you on this one to help you see. Notice as x gets really big, the y values get close to 0, and as x gets really small, the y values get close to 0. That's what horizontal asymptote is telling you. What number is it approaching? So hopefully your algebra teacher also had you write it like this. I think sometimes it just depends on who your teacher was. But this would say as x gets really small, y is getting closer to 0. And as x is getting really big, y is getting closer to 0. Did any of y'all write it like that last year? A little bit? Okay. The only difference is, in calculus, we're going to say the exact same thing, but with limit notation. So the limit as x goes to negative infinity of this function is 0, and or the limit as x goes to positive infinity, it goes to 0. So I know it's approaching 0 on the left and the right because that's where there's a horizontal asymptote. I know the horizontal asymptote's at y equals 0 because the degree of the denominator is bigger than the degree of the numerator. So there's one case. Okay, below we've got another case where if we compare the degree of the numerator to the degree of the denominator, the degree of the numerator is bigger, which means what about horizontal asymptote? Which means that your graph doesn't approach the same number on the far left and the far right. It really means that one's probably going to infinity and the other's probably going to negative infinity. Now, if you have a graph, I guess you could look at it and you could say as x gets smaller, y gets bigger. As x gets bigger, y gets smaller. Instead of saying bigger and smaller though, we're saying infinity and negative infinity. But in calculus, you could do the same thing. You could say infinity for this. You could say negative infinity for that. The problem is, what happens if you don't have a graph? What's a safer answer than saying infinity or negative infinity?
Could be anywhere.
That's zero. That's when you get 0 over 0. Infinity and negative infinity are not really numbers, they're just an idea. So sometimes instead of infinity or negative infinity, we would say
1e99.
does not exist. So because we often don't know what the graph looks like, just saying does not exist covers whether it's infinity or negative infinity. Just a safer answer. Okay, the third and only other possibility, because there's only 3 ways to get horizontal asymptotes. When you compare the degree of the numerator to the denominator, we saw what happens if the denominator was bigger in number 1, if the numerator was bigger in number 2, and now the third possibility, if the degree of the numerator is equal to the degree of the denominator, your horizontal asymptote will be at y equals leading coefficient of the numerator over leading coefficient of the denominator. So this guy has a horizontal asymptote at y equals 4. And what horizontal asymptote means is what the far left and or far right of the graph looks like. So as x gets really small, the y value gets closer to 4. As x gets really big, the y value is going to 4. In calculus, we say basically the same thing, but we use limit notation. And we can actually say equal to. So you first have to remember those 3 rules. Second, you have to know what a horizontal asymptote is telling you. And then third, you have to be a little bit used to this limit notation. But this is how we work what's called infinite limits. Infinite limits are as x approaches infinity or negative infinity. Now, if it was something else, like x approaches 3, x approaches 0, x approaches 5, we would approach that differently. We would do what we were doing last week and the week before. Okay, so let's look at a few questions on the back page here, just so you can see how quick these questions can be, and then I will have you try it on the next handout. So, when I look at question 4, this is a rational function, just a big fraction. I'm going to compare the degrees. Looks like the degrees are equal, so I know there's a horizontal asymptote at y equals 1 over 1. And what horizontal asymptote is telling me is that the far left of the graph, which this question's not asking, is 1, but also the far right of the graph is approaching 1. Okay, so in question 5, what kind of horizontal asymptote would we have in number 5? One more time? 2, because the degrees are equal, leading coefficient over leading coefficient, and what this tells you is that the far left and or the far right of the graph is approaching 2. You've already learned the hardest part of this in algebra. Now we're just making sure that you can apply it to an infinite limit. If the degree of the numerator is bigger, what kind of horizontal asymptote do we get? Okay, so it's probably going to infinity or to negative infinity, but if I don't have the graph, why flip a coin and hope that I'm right? Just say does not exist. Okay, what's the answer to number 7?
1.
And that's how easy it can be. The degrees are equal, leading coefficient over leading coefficient. If the horizontal asymptote's at 1, it means the far left and far right of the graph is approaching 1. This one just happens to be asking about the far left, but the work is exactly the same. And then the last two may look a little bit more different or more difficult, but remember with limits, we just briefly touched on this. If you want to do like two functions, two different things, you can just do them separately and then add them, or do them separately and then subtract them. So if you did the limit of this part, you would get what?
1.
Same thing here. If you did the limit of this part, you get what?
2.
So the answer to that question is 3. So if you wanted to graph this whole mess in your calculator and you wanted to scroll to the right a little bit and look as x values get bigger and bigger and bigger, the y values are getting closer and closer to 3. That's what we were figuring out with. Even if you had a calculator, it would be just a complete waste of time to even graph it. Like, it's so much easier to just do there. Okay, down here, looks like it would be 1. The degrees are equal, so leading coefficient over leading coefficient. So final answer of 0. But I can't overstate, if you don't know your horizontal asymptote rules and you don't relearn them, then these are not gimme questions. But now, if you would, take a moment and jump over to the next handout. You saw how fast these questions can be. So hopefully you can answer each of these. You got a question?
Where's the thing?
Right here.
Oh.
H of x is right there.
Oh, okay.
What?
This is number 71.
This is 71, yes.
Is this
So-
something we have to start together?
This?
Not this.
No, you can start on your own. Okay, so 71, go ahead and start answering some of these questions and see how you do. And then I will share the answers with you, and I can then go back and explain how I got the answers. I'll give you just a few minutes, because if you know what you're looking for and trying, that's all the time it should take. Okay, let's give one more minute, and then we'll check them.
So, would I say negative infinity since it goes off the graph? And I know it's going down. Or would I say does not exist because you
Either
can't
way.
see it? Okay.
Technically, if you have a graph and you can see it, negative infinity is more. Well, wait. I don't think this should be answering here. This is as x approaches -1.
And
So
there's
what-
2 points there, so it does not exist for that one.
Mm-mm.
No.
That's not what limits don't care what's happening at that value. They care what's it getting closer to from the left and what's it getting closer to from the right. Completely different than finding a point.
But I was asking about 4.
Okay?
Because, like, it's
Different. No,
11
that graph
and
has
stuff.
graph. This is a completely different question.
Oh, okay. So
Now,
just answer it.
Well, yeah, let's just answer it, but
Oh, I thought I had to refer to the graph for the whole form.
different function. Okay, let's check our answers, and then any of them that you need me to explain, I'd be happy to. But I will also add that, did you guys notice anything about the questions?
Kind of categorize.
Yeah, they weren't scrambled up very well. Degrees were equal, so leading coefficient over leading coefficient. Degrees are equal, the far left of the graph approaches 5/2, and so would the far right. Notice I don't really care what x is approaching. I don't care if it's infinity or negative infinity, same thing. Degrees are equal, leading coefficient over leading coefficient. Degrees are equal, leading coefficient over leading coefficient. Same on number 4. Same on number 5. And number 6. All 1 through 6 were the same type of question. Okay, and then 7 through something are the same type of question as well. If the degree of the numerator is bigger than the degree of the denominator, it does not have a horizontal asymptote. So this graph is probably going up forever or down forever. But since I don't know what the graph looks like, it's safer to say does not exist. No horizontal asymptote, no limit. No horizontal asymptote, no limit. Again. And again. And again. If the degree of the numerator is bigger than the degree of the denominator, that limit is going to infinity or negative infinity, so it's safer to just say it does not exist. And then the only other possibility, if the degree of the denominator is bigger, you have a horizontal asymptote of 0. So the far right of the graph is approaching 0, the far left is approaching 0. Anytime the degree of the denominator is bigger than the degree of the numerator, either infinite limit would be 0. Any of those you would like me to go over in more detail? Again, they probably really should be scrambled up, but I guess it does kind of help you see what you're looking for. Can be very easy questions if you know the little bit that you need to know for them. Alright, so again, this is the new piece today. That was it. Last year that was part of our one of our Fast Fridays, which is why it was so much shorter than the others. So I still got 2 more things for you guys today. One is, because this is a longer unit, I went through and picked out a few questions from each day that we've done. So like looking at questions 1, 2, and 3, that's the type of limit questions we learned on day 1. I think questions 4, 5, and 6 we learned on day 2. 7 and 8 we learned on day 3. 9, 10, 11, and 12 we learned last class. And 13, 14, 15 are like questions we just learned about today. So this should kind of put, give you an idea of where you stand, what question types you may need to actually try a little bit more on before we get to the next big quiz, which is still like a week and a half, 2 weeks away. So I feel like each individual day of this stuff is very manageable, but it does start to snowball, and if you aren't keeping up with what you need to know, then it can become overwhelming. So I'd like you to do this mid-unit review and finish it up. And for full disclosure, these questions are not new questions. They're exactly the same. So if you try questions 1, 2, and 3, and then you go in your binder to the first day we did limits, you're going to see where we did questions 1, 2, and 3. The exact same questions, the exact same graph, the exact same table. So I'm going to ask that you use that as your method for checking. And then like 4, 5, and 6 I think are on day 2. So you can look at your work where you should have checked those already. And just use your binder as a quick check. That's it.
Will we be able to Zoom if we end up not having school on Wednesday?
You'll get an email from the school, and I have not read it that carefully because it was sent like months ago what the plan is. But I believe the plan is the first 2 days that we have AMI. Okay, first of all, the superintendent can decide snow day or AMI day. If it's a snow day, we don't do anything for school, but we have to make it up at the end of the year. If it's an AMI day, then we do stuff for school, but we get to count it as school day. If it's an AMI day, I believe the first 2 days are assignments are posted on Google Classroom only. And so your teachers will probably have like turn in your assignment for attendance or do this exit ticket for attendance. But if we end up missing 3 or more days that we do for AMI, I think starting on the 3rd day we have live Zooms.
That's not some of my other teachers.
I'm pretty sure that's what it is. It's just that like I didn't read it carefully enough for you guys to base what you do on that. So when, if it happens, they will send that out so that you guys know what the expectations are. Okay, so this is the next to last thing. Again, some of these questions are super quick. A couple of these should take you a little bit longer. You've got these questions, should have these questions worked out on previous worksheets. So please put a good effort into that. And then finally, to finish up today, last thing I need from you is I would like to put in a grade for handout 67. That is from a few classes ago. So again, I just can't wait until our quiz and then ask you guys to turn in 10 different things. So just slowly asking from stuff that is multiple days old, stuff that you should have done anyway.
65.
You already graded this, Christian.
You want 67?
So please make sure I see that. You're welcome to turn it into Google Classroom if you'd rather do that than to hand it in, but I'm also fine if you want to hand it into the box also, or instead. You don't have to do both.
67.
67.
Okay.
I always put it on the board.
Gotcha. Thank you, sir.
I guess I'll check out one of this.
Good idea.
That one has a name on it. This one didn't have a name on it. You don't remember if you turned it in 10 minutes ago?
Well, I did turn in both.
Okay, yeah.
There were some bubble ones.
That's the only one that would be That's fine, I already got it.
Oh,
Thank you, sir.
Okay, if you need help on any of those, of course I am happy to help you, but make sure I get 67 completed so that you can get full points on that. And let me know if you need any help from the mid-unit review, because again, that stuff, you may not seem that worried about it right now, but when we add another week or two of stuff and then quiz, it's gonna seem like a lot. So it's good for you to kind of get completely caught up and everybody be on the same page. So please, not very long, but put a good effort into it.
Have you watched? I heard it was really good.
So that's right. This wasn't mine. Do we want to cut all this by